Hello, welcome to this video. In this video, we are going to go ahead and talk about solving triangle problems in context. Now, this lesson is going to be kind of the next progression in solving right triangles and then also solving non-right triangles with law of sines and law of cosines. So make sure you have gone back and you viewed those videos. You know how to use law of sines, you know how to use law of cosines, as well as your SOHCAHTOA principles in right triangles. All right. So without further ado, let's go ahead and look at solving some problems in context, some word problems. Okay, so here are just some general steps and approaches that you can use when solving context problems involving triangles. The very first thing I recommend in any word problem is drawing a picture, right? The old adage, a picture is worth 1,000 words. So draw and label the triangle with the given information. Now, it's very important that you identify, is that triangle right? Or is it a non-right triangle? Because if it's right, I can use Pythagorean theorem, I can use SOHCAHTOA to help me solve for information about that triangle and then apply it to the context. If the triangle is not right, what we're going to have to determine is, am I going to use law of sines? Like, do I have that relationship between an angle and a side? Or do I have to use law of cosines? And then step 2 says interpret the solution in terms of the context and then write your conclusion, meaning we're going to have to write in a complete sentence. Okay, so let's go ahead and look at our first example here. And we will go ahead. I recommend annotating, always trying to kind of highlight or underline key information. Okay, so a ship has been damaged in a storm and it is trying to reach safe harbor before sinking. Okay, so if you can imagine that, the ship is between a lighthouse and a dock, forming a 70 degree angle between them. Okay, so we have a ship between a lighthouse and a dock, and there's an angle. All right, the next sentence, it says, from the lighthouse, so from the lighthouse, an 80 degree angle is formed between the dock and the ship. Okay, so I'm given some information, and then we're asked, okay, so if the lighthouse is 5 miles from the dock, how far to the nearest tenth of a mile is the ship from the lighthouse? Okay, so we have some more information. So first of all, there's a lot of information. Let's go ahead and draw a picture that can kind of help us kind of understand what's going on. Okay, so I'm going to say right here, we have a ship. Here's our ship. And this ship, right, is between a lighthouse and a dock. Okay, so I'll go ahead and I'll put another point here, and I'll call this the dock, and I'll say this is the lighthouse. Okay, if you just want to use letters, you can go ahead and do that, but I have a triangle. Okay, it doesn't appear to be right, but let's go ahead and apply the information. So they say the ship between a lighthouse and a dock forms a 70 degree angle. So this is 70 degrees. Okay, they say from the lighthouse, so here's the lighthouse, an 80 degree angle is formed. Okay, so that's 80 degrees. All right, so I can easily find the other angle, right, using triangle sum theorem. And then they say if the lighthouse is 5 miles from the dock, so I know that this, side is 5 from the dock to the lighthouse. Okay, so and then here's the question that they want us to figure out. How far to the nearest tenth of a mile is the ship from the lighthouse? How far is the ship to the lighthouse? So what we want to find is this information here. Okay, so all right. So well, what we can do is go ahead and we can find this angle here, right? I know, right, that angle, and I'll call that the measurement of angle D. So step 1, I'm going to say the measurement of angle D is equal to 180 degrees minus 80 degrees minus 70 degrees, which is 30 degrees. Okay, so how does that help us? Well, I want you to see, right? Don't I have this angle and a corresponding side? So what I can do, step 2, is I can use the law of sines, right, to find x. Okay, so that means that sine 70 over 5 is equal to sine of 30 over x. Okay, and we can go ahead and solve this. So x sine 70 is equal to 5 sine 30, which means that x is equal to 5 sine 30 over sine 70. Okay, which is approximately 2.7, and then the units here, right, for our distance is miles. Okay, so what is our conclusion? Well, we can say the ship is about 2.7 miles from the lighthouse. And there you have it. Okay, part B. It says, if the ship travels at an average speed of 28 miles per hour, how long to the nearest minute will it take for the ship to reach the house? Okay, so what they give us is they give us rate. I know that the rate is 28 miles per hour. I also know that the distance, right, to the lighthouse is 2.7 miles. Okay, well, if I want to know how long, remember that time is equal to distance divided by the rate. Okay, so time equals distance over rate. All right, so that distance is 2.7 miles divided by 28 miles, okay, per hour. So this is approximately 0.1 hours. All right, but I don't want hours, I want minutes. So I'm going to go ahead and convert from 1 hour to 60 minutes. Okay, and this would equal 6 minutes. All right, so it will take about 6 minutes for the ship to reach the lighthouse. All right. Okay, so next what I'm going to go ahead and talk about is some right triangle, and I want to define a couple of things first. The first thing that I want to define in context is what's called an angle of elevation. An angle of elevation is the angle that's created between the horizontal line, kind of like your nose or your eyesight, and then like when you look up. Right? So if you see like a plane passing overhead, like when you look up at that plane, you're creating an angle of elevation. An angle of depression is the angle that's created when you look down. So if I'm looking down, say like my phone, when I'm walking and texting or something like that, right? That horizontal line from my head, right, looking down, that's called an angle of depression. And you can kind of see it here. Now, a trick to these problems is that when they give you an angle of depression, they're also giving you an angle of elevation. If we use our knowledge of geometry, alternate interior angles, I know that these two angles are congruent. Okay, so just kind of some background information there. All right, so let's go ahead and look at this example. It says David stands at the base of a building, okay, and he jogs away from the building at 2.5 meters per second. For 9 seconds. All right, James is standing on top of the building. so he's on top of the building, and measures an angle of depression of 63 degrees from the top of the building to David. Okay, so they say to the nearest foot, how tall is the building? And then they also give us a note. And whenever they give you a note, that means that you're going to be using it, right? They're giving you some information. So they want to know how tall is the building. Okay, so step one, I need to go ahead and I need to make an image. Okay, so I have a building. Here is my building. Isn't it beautiful? Okay, and James is on top, and he's measuring an angle of depression, okay, to David. Here's David. Okay, and he's running away. He's going this way. Okay, so the angle of depression formed by him is 63 degrees. So this is 63. Okay, which also means, right, that the angle of elevation is 63. Okay, so they want to know how tall is the building? How tall is it? Okay, so here's X. Here's the building. All right, I want to find that. Well, I have an angle, and I also have information too about David. I mean, David is jogging. His rate is 2.5 meters per second. Okay, so if I want to find distance, distance is equal to rate times time. So he's running at 2.5 seconds, or 2.5 meters, right, per second, times 9 seconds. So that is 22.5 meters. Okay, so 22.5 meters. Okay, so I want to go ahead and I want to find X. So can't I use SOHCAHTOA? Whoa, lights went out. They're back on. Wow. Okay, so if I want to use SOHCAHTOA, I need to know the sides that are involved. Here is the angle, right, that we're using. And the sides that are involved are the opposite side and the adjacent side. So this is looking like a tangent problem. Okay, so I can go ahead and find the height by taking tangent of 63 is equal to X over 22.5. And then I can solve for X by multiplying by 22.5. And we get the height is about 44.158 ... meters. Okay, now note they want to the nearest foot. They don't want it in meters. So what we're going to have to do is convert into feet. And this is where we use, right, they tell us that 1 meter is equal to 3.2808459. I'm just kidding, not those last ones. Okay, so we can do this, and we go ahead and get to the nearest foot approximately 145 feet. Okay, so what is our conclusion? Well, our conclusion is the height of the building is about 145 feet tall. And there you have it. Okay, I do have a practice problem for you here. I would like you to pause this video. I want you to try this. Give it a go on your whiteboards. See if you can get it, okay? All right, hopefully you pause the video. Here is the solution. And, I mean, pretty straight up. We have a drawbridge at Hogwarts that's raised, and it creates this image. Okay, and this is a right triangle, right? So anytime you involve like a building, or like a mountain, and there people are running away from it, generally it's going to be a right triangle problem. Okay, all right, so I'm going to go ahead and stop the video. We're at 15 minutes. There's going to be another video talking about more context problems. Catch you next time. Peace.